Oh, hello. It's Geert Von Dee Bee. Perhaps you have missed me in my long hiatus. Today, I'm going to talk about an issue of extreme importance from several hundred years ago, the issue of stellar parallax. First, we will begin by defining what parallax is. Parallax means when an observer moves, the objects they're looking at appear to shift. Perhaps that's too complex, so let's give a practical example. If I hold out my thumb like so, and I look at it through my right eye, and then my left eye, try it for yourself. It looks like your thumb shifts to the background. That shift is called parallax. Now, back in the ancient world, with Greek, Roman, medieval astronomers, this lack of parallax for the stars was evidence that the Earth was fixed at the center of the universe, a very commonly held belief going back to Aristotle and Ptolemy and other Greek astronomers. Let's draw a diagram, shall we? See my paper? That dot is indicating the Earth. And that dot is indicating the Earth again 6 months later. Let's say winter and summer. In the 1500s, an astronomer named Copernicus, perhaps you've heard of him, theorized that the sun, not the Earth, was at the center of the universe. Here's our diagram. The yellow ball being the sun. That meant that over the course of a year, 365 days, the Earth would have to move around the sun, like thus. So in this diagram, let's put in our star, hence the term stellar parallax. We'll make the star orange. Flip that over. The orange dot is a star, Earth, Earth, sun. At the time, they did not know the distances involved, but the reasoning was something like the following. If this is our nose, here is our eye, as in our previous example, and here is our other eye, that over the course of the year, you should be able to observe stellar parallax, my thumb being the star. So Earth in the winter, Earth in the summer, sun, and my thumb is a star. However, the problem was that no matter how carefully they made measurements, they can never measure this shift that we call parallax. Let's draw some further details. Those lines indicate observing the star in question, the orange dot from the Earth, and middle of the sun, waiting until the Earth has gone around. So middle of the winter, and the angle there, up at the top, right there. Pay no attention to that golden robot behind me. Oh, oh. That angle should be the parallax, so-called parallax angle. Now, when Galileo came along, he made telescopic observations of the moon, moons of Jupiter, sunspots, phases of Venus, what he called the ears or handles of Saturn. But none of these did anything to weaken this argument because stellar parallax was still not observed. What that meant was that if you wanted to still argue that the sun was at the center and the Earth was moving around the sun, that the stars had to be further and further away. Because as you push the stars further and further away, you can see my audience behind me is very interested in this. That angle will get smaller and smaller and smaller to the point where it's so small that you cannot observe it anymore. So your two options in the 1500s and for most of the 1600s and into the 1700s, even into the early 1800s to explain the lack of stellar parallax, were either that Copernicus was wrong, that the Earth did not move around the sun, and therefore that's why you didn't observe this little shift, or that the stars were infinitely far away. And you can guess which was the more radical position to take, at least in the 1500s and the 1600s. I hope that I've clearly explained the phenomenon of stellar parallax to you and why its lack for several hundred years was strong evidence that Copernicus, favoring the sun-centered system, was incorrect. In fact, stellar parallax was not observed until a German astronomer saw it for the closest stars in the 1830s. And even then, it's still a teeny tiny measurement. And the instruments to make that measurement did not exist until the 1800s. I hope you've learned something. I know this is different from my usual videos, but it was upon the request of another YouTuber called Deep as Flux. Until next time, signing off.